Okay, continuing on the Unit 1 review packet, we're going to go to topic 3A, B, and C, absolute value. So let's start with question number 12. So I have my absolute value and it's all by itself. There's nothing outside of it being multiplied. There's nothing being added or subtracted. So this is the part where I can rewrite it without the absolute value sign. So 3x plus 4 greater than 2. So I write the first one exactly as it is without the absolute value sign. The second one, I'm going to write 3x plus 4, but I need to change the inequality. I need to flip it, and I need to change the sign of the number on the right. So it becomes negative 2. So the first one's exactly the same. The second one, I took this and I flipped it, and I changed that positive 2 to a negative 2. So now I'm just solving inequalities. So of course I'm going to do my subtraction first. So I have 3x is greater than negative 2. And then divide both sides by 3, and I get x is greater than negative 2/3. My second one over here, I also subtract 4 from both sides. That gives me 3x is less than negative 6. Divide both sides by 3, and I get x is less than negative 2. So now on my number line, I have to decide, is negative 2/3 smaller or negative 2 smaller? Which one goes on the left? So remember, for negative numbers, the bigger the absolute value of the number is, the farther away. So I've got negative 2 and negative 2/3. Negative 2/3 is closer to 0, so it's farther to the right. Negative 2 is farther away from 0, so it's more to the left. I have open circles on both because I don't have an or equals, I just have greater than and less than. And this one, if it's greater than negative 2/3, it's going to the right. If this one is less than, it's going to the left. So this is actually an or inequality. And then my last step, it said, give it in your specified notation. This one's interval notation. So if I'm at the left, I'm all the way to negative infinity, and I stop at negative 2. And it's parentheses, not brackets, because I'm not including negative 2. It's an open circle. And I'm joining it with this set here, which I start at negative 2/3. And again, it's parentheses because it's an open circle. I'm not including it. And this one goes all the way to positive infinity. So that's number 12. So now we'll move on to number 13. So number 13, my absolute value is not by itself. I have this 2. So I need to get rid of the 2. And remember, we are not distributing through absolute value signs. But this 2 is being multiplied, and the opposite of multiplying is dividing. So I'm going to divide both sides by 2. That gives me 1 minus 2x in my absolute value signs is less than or equal to 3. Now that my absolute value is by itself, I'm going to rewrite it exactly as it is, just minus the absolute value signs. And then my second time that I rewrite it, I'm going to flip the inequality and change this. So I flipped the inequality here, and it became greater than, and positive 3 became negative 3. Now I can go and solve. So I'm going to subtract 1 from both sides. Negative 2x is less than or equal to 2. And I'm dividing both sides by a negative. That means I'm going to flip this inequality sign. So I need to say it's now greater than or equal to negative 1. And this one over here, same thing, subtract 1. I get negative 2x is greater than or equal to negative 4. Divide both sides by negative 2, and I get x, and again I have to flip the inequality, is less than or equal to 2. When I put this on my number line, the negative number goes to the left. It is smaller than my positive number. I have closed circles on both because it is greater than or equal to, less than or equal to. And this one, if I am greater than or equal to negative 1, I'm going this way to the right. This one, if I'm less than or equal to 2, I'm going this way. So this one's an and inequality. It's sandwiched in between. And then my last step is set builder. So remember, for set builder, you need to know I need to draw these brackets. I need to draw that x, this line, right? For all set builder, it's always that same piece. And it's going to end in brackets. And then inside the brackets, I'm just going to put my inequality. So this one's an and inequality. I could either write it as x is greater than or equal to -1 and x is less than or equal to 2, right? Or I could write it this way. -1 is less than or equal to x, which is less than or equal to 2. These two things are the same. It's in between. My x is sandwiched in between the -1 and the 2. I actually like this way of writing it better because you can really see that it's sandwiched in between, and it really makes it clear that this is an and inequality. But this way is also fine. All right, last question on this topic is question 14. So again, my inequality is not by itself yet. I have this +4. Because what I'm trying to do here is I'm trying to have just this part by itself before I take away the absolute value signs. So I'm going to need to subtract 4 from both sides. That gives me 11 plus 2x equals 5. Now my absolute value is all by itself, so now I can rewrite it. I take away the absolute value sign, and the first time I write it exactly as it is, and my second time I'm going to, for this one, it's not an inequality. I just need to change the sign, right? Because it could equal +5, but it could also equal -5. Because the absolute value of +5 is 5, and the absolute value of -5 is also 5. So now we're solving this equation. Subtract 11 from both sides, and I get 2x equals -6. Divide both sides by 2, and x equals -3. Here, -11 minus 11, I get 2x equals -16. Divide by 2, and x equals -8. Now remember, when we have equal signs, we need to check for extraneous solutions. So we need to basically plug this back in and see, does it work? So review on how to plug it in on the calculator. We're going to use the stow button. I'm going to store -3 for x. So I'm going to say -3, and the stow button is right here, stow, and then x. That's what it looks like on the screen. And now every time I hit x, it's going to use -3. So I want to put in the absolute value of 11 plus 2x plus 4. So absolute value is math, go over to number, and then 1. And I'm going to put 11 plus 2x. I'm going to use my toggle key to get out of there because I need to add a +4. And we're going to see, does this equal 9? Yes, so that one works. So -3 is an answer. Let's check -8. So again, I'm going to do -8 stow x. And instead of retyping this whole thing, I'm going to go up and highlight it. If I highlight and type enter, it retypes it for me. And that also equals 9. So these are both good solutions. So now for graphing this on my number line, it's just 2 solutions. So it's a filled in circle on -8 and a filled in circle on -3. That's it. There's no line. I'm not doing inequalities. So that's what I have. And then my answer in interval notation, I've got 8. Actually, and I'm including 8, so I need brackets. And I'm joining it with a set that or -8, sorry. -8 in brackets. I'm joining it with a set that includes -3 in brackets. And that is my answer to number 14. So this again was absolute value solving and graphing either equations or inequalities.